In 6.4, we're looking at logarithmic functions. And logs are very closely related to exponential functions. And so hopefully this right here, x equals a to the power of y, doesn't look too scary. I'm going to label these parts, and then we'll talk about what this looks like as a logarithmic function. So the a right here, this is the base number. This is the number that's going to be multiplied by itself a certain number of times, the base. Y is the exponent on that base, and x is the, well, I don't know, different ways of referring to it, but the answer. If you actually crunched out a to the power of y, the numerical answer you get is x. Now, a logarithmic function is this mathematical relationship, but rearranged. And so what we have is we have log base a of x equals y. Now let's talk about what this means. So everything has the same meaning it had over in this case. X is still the answer, what we got after we did this computation. A is still the base, but now instead of the answer being what we got when we actually multiplied out all that stuff, the answer now is going to be the exponent. What we're looking for is the exponent. So log base a of x equals y. To give context, let's pick some numbers. So if I were to say log base 2 of 8, log base 2 of 8, and that would equal 3. Log base 2 of 8 equals 3. And it does. Now, why? Well, remember that if we were to put this back into exponential form, it would be a little bit clearer. Log base 2 means 2 is our base. Right here, what we're looking for is the exponent. So that's 3. It goes back right up there. The answer to all this stuff actually multiplied out goes right there. 2 to the power of 3 equals 8. These are equivalent understandings of a mathematical relationship, just written a little bit differently. Log base 2 of 8 equals 3. So one of the skills that's really important for this is your ability to go back and forth between these two forms. You need to be able to go back and forth between them. Both because it'll help you in solving stuff and because it's really important for just understanding that relationship. And so I did it in the context of these numbers right here, but you are also going to see it symbolically. So I'm going to do one more numerical example, and then we'll look at some symbolic examples. You'll see what I mean here in a minute. Let's see here. Log base 3 of 1/27 equals -3. So what does this mean? Remember that the base is that right there. So that from an exponential, that's my base. Remember that our exponent is now over here. It's what it's equal to. 3 to the -3rd power equals 1/27. And it does. Remember that the negative sign means the inverse, the multiplicative inverse, reciprocal. And so it's 1 over 3 to the 3rd power, or 1 over 27. So symbolically, if I have something like this, if I have log base c of b equals a, remember that this is where the base is. So the base is right there. This is the exponent, so that's c to the power of a. And it equals right there, what you get when you actually do that number crunching. C to the power of a equals b. So you need to be able to move these things around and understand the relationship between these two forms of the same mathematical relationship. And we'll go ahead and throw in this video evaluating. You do need to be able to evaluate logarithmic functions, evaluate logs. So for example, if I said log base 4 of 1/16, I'm saying, oops, I don't know why I put L right there. Let me fix that. Log base 4 of 1/16. I'm saying 4 to some power equals 1/16. What does that give us? What are we looking for? What is the exponent that would make 4 to that power equal to 1/16? Well, hopefully, since this is a reciprocal, it's in fraction form, hopefully that tells you that it's going to be negative. And the relationship between 4 and 16 is it's squared, so -2. So log base 4 of 1/16 is -2. So if I have log base 2 of 32, that means, and it equals something, we'll say x. That means 2 to the power of x equals 32. 2 times itself how many times equals 32? That's what that's asking us. If you're not sure, just start writing out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's 1, 2, 3, 4, 5. So log base 2 of 32 is 5. So you should be able to evaluate logs, once again dealing with positive and negative exponents. Yeah, a lot to figure out there.